Good morning, all of you. So, in the last class, we have finished this comparison of isothermal and adiabatic process. I have given you one column also, or we can say a table, in which we have seen the differences in adiabatic as well as isothermal process. Okay. So today we will see some graphs which will give you idea about this isothermal and adiabatic process, right? So see here, comparison between isothermal and adiabatic curves, between isothermal and adiabatic curves. Okay, so what is the title? See, comparison between isothermal and adiabatic curves. Okay, so this isothermal and adiabatic curves in different cases we will see in this topic. So first of all, see here, number one case, when expanded, when expanded to the same volume, expanded to the same volume from the same initial state, from the same initial state. Means what we did now, whatever the initial states are there, we have expanded them to the same volume. So what type of graph you are getting? Let's see. I am plotting here a graph which will indicate this case. So see here, I am taking this pressure on this x-axis and this volume on this y-axis, isn't it? No, yes, I am taking volume on x-axis and pressure on y-axis. It is like just indicator diagram. Yes, pressure on y-axis, not on x, and volume on x-axis. So as see, this expanded to the same volume from the same initial state. So what type of graph you are getting? You see here, this is your initial state. So first graph is coming like this, and another graph is coming like this. So if we will draw this line, dotted line like this here, similarly here also, we just draw one dotted line. So now you are getting two curves. This is curve number 1 and this is curve number 2. Now here this is volume V2, this one is volume V1. So this one graph, graph 1, this one, you can see this curve number 1 is for isothermal process, isothermal, and 2 number curve indicates for adiabatic process. Which process? Adiabatic. So if we will compare here, first of all, work done. Okay, so work. So in this case, work done of isothermal is more as compared with adiabatic. So therefore, W1 is greater than W2 in this case. Second one, second point, that is final pressure. If we will consider about final pressure, then which pressure is more? Tell me. You can see here graph. If suppose we will draw this point, yes, can you see? This is P2 and this is P1. So which one is greater? P1 is greater, isn't it? P1 and this is P2. So for final pressure, P1 is greater than P2. Second one, final temperature. So in this also, which one is greater? T1 is greater than T2 for this curves, right? And one more note point I am giving you, always remember that that adiabatic curves are more steeper than isothermal, are more steeper than isothermal, curves, right? So what is the case here? See, adiabatic curves, which one? These two. So these are more stable than this isothermal. Understand? Always keep in mind. Which are more steeper? Adiabatic. So in this diagram, which one is more steeper? You see this second one. This is not more steeper. This one is more steeper. Understood? So work done, W1 is greater than W2. Final pressure, P1 is greater than P2. And then final temperature, T1 is greater than T2 in this case. Understood? What is the condition? Condition number one we have seen here. See, when expanded to the same volume from the same initial state. Means see here, this one number is there, no? Or just this point, yellow point. So this is your initial state. Yes, and this one is the curves we got for this particular case. And in this we have seen these things, what is going to happen. Clear? Understood? Okay. So next, let's move ahead and let's see in the next case. Now, second one, second case, that is, now first we have seen expansion, that is when expanded to the same volume from the same initial state. Now we will see compression. What happens in compression? So second case, when compressed, when compressed when compressed to the same volume from the same initial state, from the same initial state. Now first we will plot the graph. So So how we are getting the graph for this particular case, right? So I'm taking here pressure and volume on these particular axis as same in the previous case. Okay. So what we have taken in the previous case on this y-axis, that is pressure. What we have taken, this pressure on this y-axis, and this side volume on the x-axis. So this is pressure, this is volume. Okay. So pressure we have taken on y-axis, and on x-axis this volume we have taken. What we are doing now? Compression. So if we will plot the graphs, first I am drawing these dotted lines. Okay. This is 1 and this is 2. 1 is for adiabatic here, 2 is for isothermal. 1 is for adiabatic, 2 is for isothermal. For adiabatic and 2 is for isothermal. Okay. 1 is for adiabatic, 2 is for isothermal in this case. So what will happen here? Work done in the first case. So if we will see work done, what is more, in which case you will get more work done. So W1 is less than W2. If we will see pressure, final pressure in case of compression, so final pressure P1 is greater than P2. Second one, final temperature. In this case, what happens about final temperature? Same thing, T1 is greater than T2. T1 is greater than T2. Because I have reversed this one. See, one is for adiabatic, second for isothermal. In the first case, what is work done? W1 means W for adiabatic is greater than W for isothermal. W for adiabatic is greater than W for isothermal. Here P1 is for which one? Adiabatic. Again, the pressure for isothermal is greater than pressure for adiabatic, and same thing here also. This is for adiabatic. One is for adiabatic. So keep it in mind. This for this diagram. Don't forget this. Clear? Okay. So this finished when compressed to the same volume from the same initial state. What in this graph indicates, when we have compressed to the same volume from the same initial state, these things is going to happen. That is what work done. W1 is less than W2 and pressure P1 is greater than P2. Temperature T1 is greater than T2. One is for adiabatics. How we will read this? So work done in adiabatic process is less than work done in isothermal process, whereas pressure in adiabatic is greater than pressure in isothermal, and temperature in adiabatic is greater than temperature in isothermal during the compression. Keep it in mind. Okay. Here, as usual, you can write that this is V1 and this is V2. Yes. Okay. but here it is arrow. If you will see, this is your final volume and this is your initial volume, or you can write it as a 1 also. What is that? 1 volume in the first or initial volume. This is because arrow, you see arrow here, they are going this side they are going, means this is initial volume, this is final volume. So this is v1 and this is v2. Got it? Okay. Let's move ahead. Next, now this third one, this third case, you see what I am going to do. This third one, when this expanded to the same pressure from the same initial state, when expanded when expanded to the same pressure, when expanded to the same pressure from the same initial state, from the same initial state. Now see, if we will go back once, see the first case when expanded to the same volume from the same initial state, means what we are doing, we are expanding it to the same volume and starting from same initial state. Second case, what we have seen, this is compressed to the same volume from the same initial state. This is also expansion once, compression once at same volume. Okay. And this third case you see now, when expanded to the same pressure from the same initial state, means this here, what is the change? Pressure is same. In the previous two cases, what was the same? Volume was same. So how the graph is going to be for this case? Let's see. So if we will see here, this is a pressure and I'm taking this side on x-axis, that is volume. So what is going to happen? Let's see. So here, let us suppose I have taken pressure on this y-axis and volume on this x-axis. Yes, this is pressure and this one is volume. Now, what happens in the third case? If we will plot the graph, first see, this is the initial state. Okay, so you are getting curves like this. This is first curve and this is second curve. You can give anything, whatever the names you want. So this is the condition for this. You can see, like this graphs you are getting. So this is I am giving as a 1 and this one is 2. And now here on this y-axis, this is y-intercept, and here you see this final pressure is same. So this line I am joining, and this curve also you join like this. One minute. Okay, let me draw first this line so that I can draw very nicely. So this one I'm extending like this. Okay, and this is first curve like this. You are getting steep, and this is your second curve here only. Okay, so here is V2, here is V1, and this one is 1, this one is number 2. So what is case now? Same pressure from the same initial state. So this P2 is same in the both cases. In the previous case, you see here, like this case, same volume was there in the both cases, final volume. Yes, compressed to the same volume. So this V2 is same for both processes. In the first case, you see here, what is the case again? Expanded to the same volume means initially same, but this finally you see V2 is same in the both processes, right? Here in this case, what is same? This P2 is going to be same in the both cases, one and two. So what is going to happen here? Let's see. So here, what is work done? In this case, if we will see about work done W1 is greater than W2. W1 is greater than W2. In which case? This case. Next one, final volume. You see which one is greater? V1 is greater than V2. So here final volume that is V1 is greater than V2, right? You can see in the diagram. Next one, final temperature. Which one will be more? So in this case, this final temperature T1 is greater than T2. T1 is greater than T2. So one is what here? One is isothermal. One is what? Isothermal process. And second one is what? Adiabatic. So how you will read? Yes, how you will read? You should read like this. Work done in isothermal process is greater than work done in adiabatic process. Next one, work done one more time. Work done in which process? Isothermal process is greater than work done in adiabatic process. Next one, volume of isothermal process is greater than volume of adiabatic process. That is what? Final volume. Did I say about pressure here? No. Why? Because it is a expanded to the same pressure. If you will see this y-intercept of this both curves, you will get only one value, that is P2. So is it necessary to mention that? No, it is not necessary to mention it. Therefore, I'm just talking about this volume. So final volume, which one is greater? P1 is greater than P2. And here final temperature, you see this final temperature T1 is greater than T2. Understood? Yes, this is what when expanded to the same pressure from the same initial state. Okay. So next, last one. So this one is number 4 when compressed to the same pressure. So we have seen two cases of expansion, two cases of compression. In first two cases of expansion, we have kept same pressure, that is same volume in the first two cases, expanded to the same pressure. In the next two cases, we have kept pressure constant. One time expansion, one time compression. So let's see how this is. So this fourth case, fan compressed to the same pressure, fan compressed to the same pressure from the same initial state, from the same initial state, from the same initial state. So this time what we are doing? Compressing. Hmm? So let's see what is going to happen in this case. First of all, let's plot graph, that is P versus V graph for this condition also. So on this pressure, on this volume. And now compression. Compression means what? Gas is going to be compressed. So pressure will move more or less. Yes, more or less. Let's see. So therefore, in this case, how the curve is coming, see, from this first, this curve is going like this. and in this you are getting more further curve like this. So if we will see here, these two curves will meet at one point. If I am cutting this y-intercept, both should be at same pressure. Okay, and this one I am cutting this x-intercept for these two process in which the volume is different. Can you see? Yes, you can see here. And here, this one is second one I am giving now. This is two, curve number two, and this one is curve number one. So here, one number curve is for isothermal process. Which process this is? Isothermal. And two number process is for adiabatic. Got it? So here, which one will be V1 and which one will be V2? This one will be V2. This one will be V1. You can see on this graph. And here, this one, that is initial pressure, is, let us suppose, P2. This one is P2. This one is P1. Which one is greater now? P1 is greater. And you see, if suppose arrow, you will see this is compression. Compression means pressure will be more. That is, final pressure will be more. If suppose you are suppressing something from some initial state, so your pressure, what we can say, that time pressure is more when you are compressing. When you are expanding, pressure will be less, right? So see here what happens now in case of work done and all. So see here, in this case, what is work done? In which case you will get more, which case, always you keep it in mind. If you will observe previous three cases, always in the first case, that is isothermal case, work done is more. So therefore, W1 is greater than W2. In which case? In the first case, we can say. Next one, final volume. Which one is greater? Obviously, initial is greater, right? So final volume is less. Therefore, V1 is less than V2. V1 is less than V2. And final temperature, this final temperature, you can see this T1 is less than T2. T1 is less than T2. Got it? So one more time, I am revising you briefly from the first case. See, so isothermal and adiabatic curves, if we will see, the first case was what? Expanded to the same volume. So see here, these two processes are ending at the same volume from the same initial state. Yes or not? So this one is isothermal, second one is adiabatic, and in this, work done of isothermal is greater than work done in adiabatic. Final pressure, if you will see in the diagram, you see this P1 is greater than P2, and final temperature is what? T1 is greater than T2. Next one, we have seen this compression to the same volume, compressed to the same volume again. This first one expanded to the same volume, expanded to the same volume. Can you see? Expanded to the same volume, same volume. In the next case, we have seen this compressed to the same volume, compressed to the same volume. So here work done is what? Greater. In which process? Adiabatic. Only this case is. In adiabatic process, it is more when we are compressing at the same volume. Final temperature is greater than in the second case. That is, adiabatic is greater than this one. Right. Next one, temperature in adiabatic is greater than temperature in second case. So here also you see work done in isothermal process only more than the adiabatic process. Next one. Here again, this expanded to the same pressure, same pressure. So here work done is W1, that is for isothermal, is greater than W2. Final volume V1 is greater than V2 and final temperature T1 is greater than T2. Next one, we have seen this last case, that is the compression to the same pressure, same pressure. One time we kept same volume, expanded, compressed. One time we have kept same pressure, expanded, compressed. So here work done is what? Again greater in isothermal only. Volume, if you will see here, this volume for 1 is greater than volume for 2, and final temperature is T1 is less than T2. That is, temperature of adiabatic process is greater than this isothermal process. Understood? Right? So note down this, revise well. Okay. If you have doubt, just call me. Revise once properly that yesterday's class table and this one, these curves and all. Okay, so let's stop here. Bye for today.